Hi class. So today we are going to be focusing on equal signs and equations. Our objectives for this concept are going to be to review the equal sign. We're going to understand the concept of the equal sign, and then we're going to practice determining equality. So what is the equal sign? So we have our trusty little equal sign right here. And what we are used to seeing with the equal sign is almost like the answer is. So for example, we're used to seeing, for example, 1 plus 1. I hope we're all able to do this simple math in our head. So we all know that simple 1 is 2, or 1 plus 1, the answer is 2, or 1 plus 1 equals 2. So the focus today is we are focusing on what this sign right here means. Basically, this is saying that 1 plus 1 is the exact amount or the equal amount of 2. If I were to have a balance beam and I had 2 on one side and 1 plus 1 on the other, they would be in balance. They would be equivalent to one another. That is what this sign is expressing right there. It's not just the answer is like we're used to seeing. So let's do another example. Trusty little equal sign. So we have 5 minus 2. Take a moment, do the mental math, which I hope we can do. So 5 minus 2 obviously is 3. This expression is accurate because 5 minus 2 is the same thing as 3. If I were to say 5 minus 2 to somebody, that is the same thing as me saying 3, essentially. Okay, so what does the equal sign represent? This is going to be our vocabulary term, and I would like you guys to write down this definition into our notebooks. The equal sign represents the concept of equality and links two math expressions that have the same value. Go ahead and pause the video and take a moment to write this into your math journals. Okay, so now we're going to go into some examples. These are going to be expressions that use the equal sign, and I'm not sure if we've seen this before, so let's pull out our trusty equal sign. We have 2 plus 8. Now, I know we all know that 2 plus 8 is 10. We should be able to do that in our head at this point. However, the expression 2 plus 8 is equivalent to 5 plus 5, since we know 5 plus 5 is also 10. Therefore, these two expressions are equivalent to one another, and that is what this symbol, our equal sign, is saying. Another example, we have 4 minus 3. That should be a pretty easy one. For now, I want you guys to pause the video, and I would like you to write down in your math journal your own equivalent expression that is going to equal 4 minus 3. Go ahead and pause the video and see if you can challenge yourself to do that. Okay, so 4 minus 3, as we know, is 1. Go ahead and share your examples that you came up with on your own. My example is 99 minus 98. 99 minus 98 is equal to 1, the same way that 4 minus 3 is equal to 1. Therefore, 4 minus 3 is equivalent or equal to 99 minus 98. We'll do a couple more examples to show you guys the relationship between the equal sign and other different types of math problems. It doesn't always have to be the same type of number. So for example, I have a decimal. I have 25 hundredths. I hope we know what 25 hundredths is equivalent to in our fraction version, but 25 hundredths is equivalent to 1/4. Think about our pizza pie. When we cut our pizza in half and then into fourths, we have 25 hundredths of our pizza left. Another example, we have 1 75 hundredths. A little trickier, but 1 75 hundredths, hopefully you know, is equivalent to 1 3/4. Go ahead and write down this example in your math notebook under examples and strategies of the equal sign. Now we're going to go into some non-examples. So when 2 sides of the equal sign, our two expressions, do not equal one another or are not equivalent, you're going to see this sign. This means non-equivalence. These two sides are not equal to one another. If I had a balance beam, my balance beam would be off balance. It would not be even. So let's get into it. We have 1 plus 1. Previous example, we all know that 1 plus 1 is 2. 1 plus 1 is not 3. Therefore, I'm going to use this symbol right here in the center to show that 1 plus 1 is not equivalent to 3 because 1 plus 1 is 2, not 3. Try another one. 5 minus 2. So from our previous example, we know that 5 minus 2 is 3. It is not 7. That would be 5 plus 2. So 7 is not equivalent to 5 minus 2. Let's try a couple more. We have 2 plus 8. We know 2 plus 8 is 10. So if I were to put 5 plus 10 next to it, which is 15, these two expressions are not equivalent. 2 plus 8, which is 10, is not equivalent to 5 plus 10, which is 15. Try one more before we go into our practice. 4 minus 3. We know from our previous example that 4 minus 3 is 1. 99 plus 98 is not 1. And matter of fact, it is very far from 1, as you guys can see. Therefore, it's very obvious that these two expressions are not equivalent. You shouldn't even need to do the mental math to notice that. So, hopefully we all understand this concept. We are going to practice in our math journals right now. You're going to use the equal sign or the non-equivalent sign right here to complete each expression. Our first expression is in red, our second is in blue, our third is in green, and our fourth is in purple. You are to write down these expressions and use either the equal sign or the non-equal sign to complete each expression. Pause the video and go ahead and do that before we answer. Alrighty then. So 17 plus 4 and 21, are those two equal or not equal to each other? They are equal. 17 plus 4 is 21. Therefore, 17 plus 4 is equal to 21. Next problem, 250 and 200 plus 500. Are these two equal? They are not equal. 250 is not equivalent to 200 plus 500 because 200 plus 500 is 700, not 250. Therefore, those two are not equal. Our next expression, 3 times 4 and 18 minus 3. Are those two equal? They are not equal. We know this because 3 times 4 is 12. 18 minus 3 is 15. 12 is not equivalent to 15. Finally, we have 3/10 as well as 3/10. Hopefully you noticed, well, I guess you can call this 30 out of 30 hundredths or 3/10. This one's a little tricky. I know we struggled on our assessment with this one. 3/10 is equivalent to 30 hundredths. All that zero is a placeholder. So with this expression, basically there's a bunch of zeros behind this 3. So 3/10 is absolutely equivalent to 30 hundredths. I hope you guys learned a lot about this math concept today. I hope it clarified some of your confusion about equal and not equal.